The incorporation of a freshness indicator in a message is a means of thwarting message replay attacks. Message replay attack is any kind of attack that has been recorded and replayed at some later date. For example, an instruction to a bank to transfer a sum of money from account A to account B could be recorded and replayed sometime later to fool the bank into making a second payment to account B. The section introduces 3 methods for indicating freshness: timestamps, sequence numbers, and nonces. A digital timestamp is analogous to a conventional postmark on an envelope. It provides some check of when a message was sent. It is typically used for logging events, in which case each event in a log is marked with a timestamp. Sequence numbers are an alternative way of indicating freshness. If entity A is sending a stream of messages to entity B, he can bind each one to a sequential serial number, and encryption will prevent an eavesdropper from altering any sequence number. If entity B is suspicious, he can check that the numbers in entity A's messages are incremented sequentially. It would be a straightforward matter for him to spot a replayed message, since the sequence order would be incorrect and its number would duplicate that of an earlier message. Nonces is the third method of freshness indication that makes use of an unpredictable value in a challenge-response sequence. It is often a random number issued in an authentication protocol to ensure that old communications cannot be reused in replay attacks. Access control are approaches used to restrict access to networks. Password can be thought as a type of key that enables a key holder to gain access to a particular resource. An effective password, technically speaking, is one that can resist both dictionary and brute force attacks. Firewalls play an important role in restricting and controlling access to networks. A firewall is normally implemented within a router or gateway and will monitor incoming and outgoing traffic at the boundary of the protected zone. It is a device that denies external hosts access to selected and secure services within the protected zone. A firewall provides the means to implement some of an organization's network security policies and may be transparent to users of the network in terms of its presence and the level of inconvenience caused. This depends on the type of firewall and the policies that are implemented. It is a device that denies external hosts access to selected and secure services within the protected zone, while also denying internal hosts access to insecure services outside the protected zone. A packet filtering router either blocks or passes packets presented to it according to a set of filtering rules. Filtering rules are based on various features of the service or protocols involved, including the packet header information, that is, IP source and destination addresses, the encapsulated protocol being used, that is, TCP or UDP, the transport layer source and destination ports, the ICMP, Internet Control Message Protocol, message type, the incoming and outgoing interfaces for the packet. An application-level gateway is implemented through a proxy server, which acts as an intermediary between a client and a server. A client application from within the protected network may request services originating from less secure networks, such as the Internet. After the client's authentication has been confirmed, the requests for services are relayed onwards by the proxy server. An application-level gateway relays requests for services at the application level. Policy decisions to block or permit traffic are based on features identified in the application. Application-level gateways typically provide proxy services for email, telnet, and the World Wide Web. because an application-level gateway is exposed to greater risk than the hosts it protects. The proxy server normally takes the form of a specially secured host, referred to as a bastion host. This is specifically designed to be more resistant to attacks than other hosts on the protected network. An application-level gateway provides code specifically designed to enhance regular checking for software bugs is used, and each proxy service is designed to operate independently of others so that installation or removal of a service can be undertaken without affecting other services. Viruses and worms may also be screened. Access to memory drives on the gateway is severely restricted to minimize threats from Trojans, and user logon is not allowed. Other threats that could be countered using this type of firewall include those arising from importing macros. A circuit-level gateway operates at the transport layer of the OSI, or Internet Reference Models, and, as the name implies, implements circuit-level filtering rather than packet-level filtering. It checks the validity of connections at the transport layer against a table of allowed connections before a session can be opened and data exchanged. A circuit-level gateway acts as a proxy and has the same advantage as an application-level gateway in hiding the internal host from the serving host, but it incurs less processing than an application-level gateway. However, the main disadvantage of a circuit-level gateway includes the absence of content filtering and the requirement for software modifications relating to the transport function. Implementation within an application-level gateway allows screening to be asymmetric, with a circuit-level gateway in one direction and an application-level gateway in the other. You may wish to attempt the following learning activities. Their possible solutions are found at the top right of the window player.